Another form of analysis is called real-time. The analyzer continually updates the spectrum while dropping older information. We are now real-time analyzing the random signal. My reason for changing the analysis method is that we're going to insert a filter and restrict the frequencies which reach our readout and your ears. First, we'll listen to a broad spectrum, and now we'll insert the filter. I've pre-adjusted the filter so it passes signals from 500 to 1,000 hertz. To save time, we are real-time averaging 4 spectra. Note the change in sound. Let's do it again. Filter out. Filter in. Filter out. Filter in. Now we'll drop the filter's lower limit to 0, such that the filter passes from 0 to 1,000 hertz. Notice the change in sound? And now we'll gradually reduce the filter's upper limit from 1,000 hertz to 800 hertz to 600 hertz to 500 hertz. Anytime we restrict the bandwidth, a few moments ago it was 2,000 hertz wide, but now it's only 500 hertz wide, we cut down on the signal strength reaching your loudspeaker. We'll compensate by increasing the magnitude of our signal. Now that we've increased the loudness, do you recognize the sound? I hope you are reminded of a rocket engine firing or a jet engine's exhaust. Now we'll restrict the lower frequencies by bringing up the filter's lower limit. 20, 50, 100, 200, 300, 400, 500 hertz. This again reduces the magnitude of the signal being measured. We'll increase the loudness. Continue to notice the change in sound. Because we've brought both filter frequency limits to 500 hertz, the only signals coming through the filter are those close to 500 hertz. On the frequency display, you can see the spectral characteristics of the filter we've been using. This particular filter is not very sharp. The time history is beginning to look a little like a sine wave. However, it's not a true sine wave because its magnitude continually varies in a random manner. This suggests to us how a structure that happened to have a natural frequency of 500 hertz would respond to a broad spectrum random vibration input. When there is strong 500 hertz excitation, there will be strong 500 hertz response, but only then. We are looking at a relatively narrow band response to a relatively wide band input.